Greetings, madam. I'm Sid Eileen, and I'm the group leader of Group 3, and our topic that we chosen is metrics. My group members have To Yu Han, Hua Zixian, and Wong Hai Xing. This is our table of contents. The first one is the introduction of metrics. The second one is the features and the functionalities. The third one is benefit and challenge. The fourth one is the design of website. And the fifth one is the examples. The sixth one is our summary of the project. And the last one is our task distribution and the members' contribution. And now we will start for our introduction of metrics. And I'm in charge of our introduction of metrics. So first of all, what does matrix mean? Matrix is a rectangular array, table of numbers, symbols, expression that arrange in rows and columns. Matrix is used to represent a mathematical object or a property of such an object. Matrix has a wide application in engineering, physics, economics, and statistics, as well as in various branches of mathematics. And before this, it was not called as matrix, but a certain number that has associated with a square array of numbers called as determinant when it was first recognized. The term matrix was introduced by the 19th century English mathematician James Sylvester, and Arthur Cayley, a mathematician, saw as a friend of James Sylvester, and he developed the algebra aspect of matrix in the 1950s. As Arthur Cayley had recognized, there were certain sets of matrices that can form algebra systems in which the ordinary laws of arithmetic, such as associative and distributive, were valid, or in commutative law, it was invalid. And hence, our types of matrices that we study at the secondary school or in universities have such as rectangular matrix, square matrix, identity matrix, and so on. So now we will see a bit about the types of matrix at the other slide. So here is our types of matrix. The first one is square matrix. Square matrix is where the number of rows and columns are equal. So let us see this. So we can see the rows and the columns were equal, so it's in the order of 3 times 3. And the second one is diagonal matrix. Diagonal matrix is in which all the elements except in the principal diagonal in the square matrix are 0. So what does that mean about except in the principal diagonal? So we can see here the diagram. In the diagonal shape, there has the numbers 2, 3, and 4. And except the diagonal shape is all 0. So this is the characteristic of a diagonal matrix. So the third one is scalar matrix. Scalar matrix is in which all the elements in the diagonal of a diagonal matrix are equal. So it is the same as diagonal matrix. In the diagonal shape, you can see here is all the same number, -7, -7, -7 here. But except the diagonal shape is all 0. So this is scalar matrix. And the final one is unit matrix, or you can say identity matrix. So unit matrix is in which all the elements of the principal diagonal in a diagonal matrix are 1. So it is quite similar like the diagonal matrix we said before and the scalar matrix above. We can see the numbers in the diagonal shape is the same, 1, 1, 1, all 1, and except it was all 0. So this is my introduction of the matrix, and the next one is our features and functionalities of a website.
Hi everyone, I'm Pan Zixian. Now I'm going to introduce the feature and functionality of the website. On the website, we can see that there are numerous options for selecting the type of question you want to answer, such as basic metric, metric types, metric operations, metric transpose, skew symmetric metric, metric transformations, invertible metric, and more. If you cannot find the questions, you can use the search button on the website. Each type of question have 10 questions. After the educator finishes his lesson on matrix, students can search this website to do the revisions. Therefore, students can try to do the question first. Next, after all of the questions are done, they can click the View Answer button to check if their answers are correct or not. There will be an explanation for each question when they click the View Answer, but it will only use words to explain how to solve the questions. In addition, there are also some exercise and tests at the bottom of the website. The educator can give some tests to the student to ensure they understand about matrix and see what grade they will get after finishing the test. In the test questions, there are answers that can be checked afterward, and students can check their answer after submitting the test questions. Through these websites, students can learn the knowledge of matrix. They can also practice the question on the website before the test given. Later, they can check and study their answers with the answer and explanation on the website. On the other hand, educators can give the test to the student to ensure they understand matrix and see what grade they will get. Even though the website is well established, there are still some challenges facing the students and educators. Some students may feel bored while browsing this website because the colors of the website are only black and white and are not colorful. Besides, the design of the website is very simple and monotonous, only directly displays the question and answers. As the saying goes, visual effects will influence a person's mood. Therefore, the visual effects of the website will reduce the student motivation to do the questions. Furthermore, the answers in the view answer are poor because they only use words to explain how to solve the question without explaining the step by which the answer was derived. In this case, students will be confused and will not fully understand the answers. Afterward, the educators need to teach students again step by step to ensure they really get the knowledge about matrix. Therefore, this website still needs some improvement.
Good morning, madam. My name is To Johan and my ID is 1211209010. During the next few minutes, I will present the design of website. So now I will go to the student version to have a better explanation and do the question together. We have some extra note before the question in the quiz too, so let's get started. Matrix is a rectangular array or table of number, symbol, or expression that are arranged in rows and columns. Aij is the entity. The capital letter A is a represent of matrix. It can also be another letter. However, I means rows and J means column. For example, A32 means that the matrix have 3 rows and 2 columns. The transpose of a matrix is simply a flipped version of the original matrix. We can transpose a matrix by switching its rows with its column. We can take a look at the example. The row of number which is 6, 4, and 24 become the straight column. The transpose of the matrix is denoted by using the capital letter T in the superscript of the given matrix. So don't forget to write the T at here after the transpose. So now is the type of matrix terms. As my previous member Eileen said, there are 4 types of matrix, which is zero matrix, diagonal matrix, scalar matrix, and identity matrix. Zero matrix means all the entity is zero. Diagonal matrix means the term of the main diagonal are all zero. You can also understand that it's a matrix having non-zero elements only in the diagonal running from the upper left to the lower right. Besides, scalar matrix show that all the diagonals are equal and the off-diagonal elements are zero. Last is the identify matrix. It shows all the diagonal elements are equal to 1. So now we are going to look at the calculation of matrix, which is determinant, addition, and subtraction. So determinant, the formula is AD minus BC. So we are going to look at the ABCD at the matrix. A is 2, B is 1, C is 3, and the negative 4 is D. So follow the formula is A times D minus B times C. So it's 2 times negative 4 minus 1 times 3. So the answer is negative 11. So now is the matrix addition and matrix subtraction. The matrix addition is like the normal mathematics. We just need to put the first place of the matrix, which is 3, and the first place of the second matrix, which is 4, together. 3 add 4, which is 7. So the other places is same at the first step. Matrix subtraction is also have the same step like the matrix addition. It's just put the minus in the middle, which is 3 minus 4 equals to negative 1. So now we can go in to look at the question. A32 equals 2. So A32 means the matrix got 3 rows and 2 columns. So 3 rows is 1, 2, 3, and then 2 columns 1 and 2. So the answer is this one. The second question is the transpose of the matrix is denoted by using the letter what in the superscript of the given matrix. So the letter is, I just mentioned before, is capital letter T. Which of the following is not scalar matrix? Scalar matrix is scalar matrix show that all the diagonal are equals and the off-diagonal elements are 0. So 3, 3, 3. These all are equals, but these are not. So the answer is this one. What is the diagonal matrix? Diagonal matrix is the term of the main diagonal are all 0. Find the determinant. The determinant has the formula which is A times D minus B times C. So A is here, B, C, and D. So we need to find out A times D first. A times D is 8 times negative 3. 8 times negative 3 is negative 24. And then we need to find out the B times C, which is 15 times 7. So is 105. So negative 24 minus negative 105. So the answer is negative 129. So the next question, find the value of y. Y is at here. Also, okay. So y plus 0 equals to 2, same as the simple mathematical calculation. We just need to find out 2 minus 0, which is 2. So y equals to 2. Okay, so we just finished the quiz. So that's all for my presentation. I will pass my presentation to the next member. Thank you.
Hi, my name is Wong Kai Sing and my ID is 1211209077. Our topic is matrix, and this is one of the example of the matrix Cramer's rule. And this is the first question. How to do is form a matrix form first, and then and then we need to do is form 2 times 2 matrix form. How to do is we use the first one and we cover it the rows and columns. After that, we can see didn't cover it will be the 2 times 2 matrix form. And then the first one is plus, second is negative, and third one is plus. This is the formula. So plus negative 1 minus 1 plus 1. After that, do the determinant and then multiply it together, and we will get the answer is 4. Next is dx, same with before, but the x column will change to the answer. So the answer we'll get is 4. dy, same with before, but column y will be changed to the answer. So the answer will be 8, and dz will be 12. So after that, we calculate the x, y, and z. How to calculate is dx over d. But at the y is dy, and z is dz. So seems like it's the same formula, but different things. So x will be 1, y will be 2, and z will be 3. Now we're looking at the second question. Same with before, d will get 6, negative 6, dx will get 0, dy will get negative 6, and dz will get negative 12. After that, we calculate x, y, and z, and x will get 0, y will get 1, and z will get 2. Looking at the multiplication of two matrices. First thing we need to do is first row and first column. How to do is multiply first one, 2, multiply 2, plus multiply second one. Negative 4 times negative 1. After that, we just continue to second column. Then done the second column, we redo again with second row. Same thing, first column and second column. After that, our answer we'll get is 12, negative 12, 10, and 6. After that, we looking at second question is same with before, but just 3 times 2 and 2 times 2. So looking at the first row and first column, and multiply plus and multiply it together. So our answer we'll get is 2, 6, 12, 16, 5, and 0. But some question didn't have any solution like this one. 1 times 2, 3 times 2. But at the back and in front of the dimension is not same, so this one has no any solutions. Now we're looking at the inverse matrix. How to do is 1 over determinant and the inverse reserve matrix. How to do is AD 1, 4 will reserve it, and then BC like 3 and 2 you add on minus. After that, we calculate the determinant and multiply it together. We'll get minus 2, 3 over 2, 1, negative 1 over 2. We do the same thing with second question M. First is 1 over determinant and resolve the matrix. After that, calculate it and times together. The summary of the project is matrix is a rectangular array or table of number, symbols, or expressions that are arranged in rows and columns. Also, we have learned that notation, transpose, and determinant matrix. And then there's a lot of matrix like zero, diagonal, scalar, and identity matrix. Also, we have addition and subtraction matrix. That was simply just plus or minus. We found that students prefer a simple design and simple colors over a direct website. because simple design and simple colors makes math on the web looks more playful. Then students will improve their math skill through the website, such as Sound Foundry and Math is Fun. Because those websites provide question and answer with explanation to help students solve the problems. If students have done the question or do not know how to do the question, they can check the answer by clicking the Will Answer. That's all for my presenting, and this is our task distribution. Thank you.